In this video, we are going to discuss about singleton with the double check locking. A absent-minded person who always wants to double check everything. One fine day, he was in a hurry to go to college where he works as a professor. He checked whether he has taken books, notes, he wore sandals, he took umbrella, he ensured everything but forgot to wear trousers. He ran fast from his home to catch his bus, but everyone in the bus stop were laughing at him. Dog chasing him when he walked over roads and he came back to home again. After that, he realized he forgot to wear trouser. He realized he forgot to wear trouser. It's a joke, which I remember from a movie while thinking about double checking. Okay, now you can see here in example twice we checked for null before and after locking object. We shall discuss in detail why do we need to do this with implementation. Here I have created two threads to invoke getCricketBall method to return instance of the singleton class. For both the threads, I have given names along with the main threads as you see here. I have put a breakpoint in three different places to understand what is happening. If you see by right clicking on these breakpoints actions, it is printing texts such as getCricketBall method invoked along with the counter variable value and thread name. In this breakpoint, it is going to print when CLR executes this lines of code how many times lock object invoked. Here same way it prints in the output window like object creation invoking times. Why I declared these counter variables as volatile, we shall see. I am printing these messages in three different places to understand how many times threads invoking these lines of code and executing it, so that we better understand the why we need to double check for the instance variable null condition before and after the locking on object. That's fine. Why volatile? When you see volatile keyword before other than double and long data types, it means multiple threads or multiple CPUs, you can say, accessing these field variables. The value of these variables which are marked as volatile will be the same for all the threads, which means assume that you have two threads. Assume that you have two threads, thread 1 and thread 2, each trying to access the number variable which is int data type. You can see in this picture thread 1 and thread 2 is having its own cache other than the main memory. When thread 1 tries to increment its value for this variable number which is marked as volatile, it updates its own cache and flushes it to main memory. When thread 2 tries to access the value of the variable at the same time, he would get wrong data. Instead of 1, he would get 0. When one thread is interacting with the data in the cache and the second thread tries to read the same data concurrently, the second thread might read an outdated version of the data from the main memory. This is because when the value of the non-volatile object is updated, the change is made in the cache of the executing thread and not in the main memory. However, when the value of the volatile object is updated, not only is the change made in the cache of the executing thread, but this cache is then flushed to the main memory. And when the value of the volatile object is read, the thread refreshes its cache and reads the updated value. Although volatile keyword can help you in thread safety in certain situations, it is not a solution to all of your thread concurrency issues. You should know that marking a variable or an object as volatile does not mean you don't need to use the lock keyword. The volatile keyword is not a substitute for the lock keyword. It is only there to help you avoid data conflicts when you have multiple threads trying to access the same data. Okay, we shall run and see the output and understand. Just ignore the console output window as we are not interested in the output. You can see here that in the output window, object creation invoking times, it is executing only once, which means object instance gets created only once. Oh good, our implementation of singleton works fine. But by reading the how many times lock is applied on this object and get cricket ball method invoke text in the output window, we can understand each thread, main thread, thread 1, thread 2 tries to enter these lines of code, and even after applying lock on the object, and due to the double check condition we applied ensures that it never breaks singleton. Counter variables, what I have just shown here is just to understand the volatile keyword. It is nowhere related to singleton. Thanks for watching and listening to me. Join me in next session.